Hey everybody, Mr. Bowman here. In this video, we're looking at 2.12 probability methods. In particular, we're focusing on all the achieved questions for the 2024 exam. If you're wanting the achieved questions from 2015 onwards, check out the link in the comments to this one, and then you'll be able to find all of them there. So let's get on with question number 40, and we've got a sports survey happening here, and it's all about how many hours of participation they had in terms of some kind of physical exercise, sports, PE exercise, or just for fun. The results show that students or young people between 5 and 17 had a mean of 10.8, had a standard deviation of 3.2. It can be modeled by a normal distribution. So the focus of this question is pretty clear, right? It's a normal distribution question. And the question has asked us, find the probability that a randomly chosen young person spent between 6 and 10.8 hours for their physical activity for the week. So because this is a normal distribution question, you've got to draw your normal distribution curve, and below that you've got to have all your calculator inputs, and then finally you answer the question. If you're missing out any of that info, you might not get full marks and you might be a little bit disappointed with your outcome. So let's start that. So I'm going to draw the line down the middle. There's my mean, and I was told that was 10.8 from the question. Top right up here, I normally write down the standard deviation, and I know that's 3.2. And again, that comes from the question. I now need to shade in my portion that's relevant from the question. So in this case, it's between 6 and 10.8, which is the mean. So it's this kind of shaded area here that we're trying to calculate. So when you're thinking of the calculator set up for normal distribution, if you need help with that, just comment and I'll reply with a link that will help you out. But the first thing you need to enter is your upper. Oh no, correction, actually, the first thing you're going to enter is your lower, and that's the lowest area, or the lowest side of your shaded area, which in this case is 6. We then need the upper that I accidentally wrote earlier. So my upper, that's the upper portion of my shaded area, that's 10.8. Following that, you always enter the standard deviation, which is 3.2. Put a dot there just to clarify that. And then finally, we've got the mean of 10.8. And when you put that in your graphics calculator, we had a probability of 0.4332, and that had a 4dp rounding. So hopefully you got that if you put that in your calculator. Again, if you don't know how to get that on the calculator, kind of just hit me up and I'll help you out. So we're now on to question number 41. Down the bottom there, this continues from the previous one. So we knew the mean up there and we knew the standard deviation over there. So the question simply says, find the probability that a randomly chosen young person spent over 16 hours. So it's going to be the same approach. We're going to need to draw our normal distribution curve. So our mean down the middle was the 10.8. Our standard deviation up the top right there was 3.2. The shaded area that the question is asking me to investigate, I'm going to put 16 over there, and I'm going to shade in everything above that because we're looking into that. The only other issue I've got here is I don't have an upper identified here. So when you have an upper, just a reminder, the trick I tell my class, put in 5 nines as your upper, or if you're dealing with the other tail here, you could have put on negative 5 nines. That's really just a big number, so the calculator kind of gets all that there. So let's start doing our calculator inputs. We know that the lower is the first input that's needed, and that's going to be 16 in this case. The upper, as I said before, that's going to be my made up big number, so that's going to be 5 nines. My standard deviation is still unchanged, that's 3.2, and my mean, well, that's going to be unchanged too, that's 10.8. So when I do that, plug it into my calculator, I got 0.0521, and hopefully you are able to get the same on your calculator as well. Okay, we're now on to question number 42, and this one I made it a bit bigger because they gave us a tree and we're actually able to fill it out. So there's a whole bunch of information up here, and what I'm going to do is I'm going to read the question down here just to see what I'm actually looking for, and then that'll help me process the information. So I've got, what is the probability that a random app user is under 18 and used it to prepare for travel? So looking at my tree, I can see my under 18-year-olds here, and I can see my travel here. So I'm looking for this branch here, and I've actually already got the 0.22, so I'm really just looking for the probability of that travel if they were under 18 type branch. And hopefully that's hidden in the text there, or if it's not there, hopefully I've got enough information to then figure out what that might have been. So checking out all the numbers in this area here, we've got 22% of the users, that's actually the number we've already got there, were age 18 and under. 35 were between 18 and 30, that would have been here if we needed it, and the rest you would have been able to calculate that by minusing both of those off by 1. Of those who were under 18, 3/4 of them were learning a language for academic purposes. That's my top branch here. 15% were learning it for travel, and then the remainder were looking at for personal reasons such as family. But that information, that 15%, is exactly what we're looking for. That's this branch here. So that's going to be 0.15. So we've got all the information we need, so we can now actually answer the question. So if we're trying to find, the probability that someone was under 18 and using the app for travel purposes, we're going to multiply my two branches together. So it's going to be 0.22 times 0.15. So that's going to be equal to 0.22 times by 0.15. And when you plugged it into your calculator, hopefully you're getting the same as I did. I got 0.0333, and that had a 4 dp rounding. So the working for that one was quite easy, but obviously breaking down the messy text up here was the crux of that issue. And we're on the final achieve question, question number 43 for this exam. And I think this is probably the easiest achieve question I've ever seen in a level 2 probability exam. So hopefully you're going to get one of these when you're sitting it. But the question really is, we've got a whole bunch of information on the table, and again, I'm not really going to read this until I figured out what the question's getting at first. What's the percentage, so noting we're going to have to go times 100 at some point, what percentage of participants developed MCI? And this bit was really easy. I could see developed MCI here. So I had a total MCI number, and I got the grand total over there. So I can figure that out by forming a fraction, timesing it by 100. So the probability that someone developed MCI is going to be equal to 396 divided by 964, timesing that by 100 to get the percentage that they've asked for, and that there is 41%, and that there I rounded to 0 dp because it's really close to 41% anyway. So as I said, outrageous how easy that achieve question was. Hopefully you're going to get a couple of those easy ones in your exam.